These are the notes that you took, hopefully, in class with your teacher for 6.4. The notes are sort of the formalization of the definitions for the transformations. So, the first transformation we'll look at is translation. Translation is a transformation that moves points the same distance and direction along parallel lines. So what that means is if I took a straight edge and I connected B to B prime and A to A prime and C to C prime, I could say two things about all of these lines. First, that they are all parallel to each other. And second, that they are all the same length. And we can write that in two statements. We can say that B prime is parallel to A prime is parallel to C prime. We can also say that B prime is congruent to A prime, is congruent to C prime. And let's indicate that these are all line segments. The second transformation that you have been working with in this module are rotations. Rotations are a transformation that moves points the same direction along concentric circles and through the same angle of rotation. So what that means is if I drew a circle with center K and radius NK, that N prime would be on it and that it would have the same angle as AK A prime. So let's check that out. So the first thing we're going to need to do is we're going to need to connect N to K. That way I have an angle to measure. Then I'm going to need to make a circle. And I'm going to make not a full circle since my paper, I don't want to waste paper, but as much of a circle as I can. And then I want to connect N prime to K. And I then want to measure this angle. So I now can see that N and N prime, although mine is a little messy, are on the same circle. And I'm then going to measure this angle. And this angle is about 106, 107 degrees. So the question is A prime, one on a concentric circle to the circle that goes through N prime, and two, will the angle AK A prime be 106 degrees? So again, let's start. I'm going to turn my paper for just a moment. Start with drawing the ray from A to K and from A prime to K. We then are going to make our concentric circle. So K to A. And we can see that they are going to be concentric circles. They have the same center, K, but they're inside each other. They won't intersect. It's almost like if I kept drawing more and more concentric circles with the center K, that I would have a bullseye kind of shape. So now we have to measure the angle AK A prime, and it looks like it's about 110 degrees. So let's mark that as 110 degrees. So not exact because I'm a human being and my drawing is not perfect. However, we can see that these are pretty close to being perfect concentric circles and pretty close to being the exact same angle measure. So we can see that that's what the definition of a rotation is. It took n and moved it to n prime along a circle, took A and moved it to A prime along a concentric circle, both with center K, and the angle that is formed by n, k, n prime, and a, k, a prime are the same, or close to the same. The last transformation that you worked on was reflections. So reflections, we say, is a transformation that moves a point. Oh, I didn't finish the definition. Sorry about that. Reflection is a transformation that moves points across a specified line of reflection so that the line of reflection is perpendicular is the perpendicular bisector of each line segment connecting corresponding pre-image and image points. So I'm looking here for perpendicular and bisector. So what I want to do here is I want to have the line that goes from K to K prime and from L to L prime to be perpendicular bisectors to my line of reflection M. So in this case, it's going to be a little bit harder to show this given that we don't yet have a way to construct this with our tools of straight edge and compass and protractor. But we'll do our best. So the first thing we're going to do is draw the line that connects K to K prime and L to L prime. And just, a quick measure, I can measure the angle from the line M between the lines K and K prime. Oops, there we go. And it is just about 90 degrees. And then I can do that same thing for the line L prime. L prime to M, and it's also about 90 degrees. So I can indicate that. 90 degrees, 90 degrees. I then can measure the length from this angle to K and K prime by using the, if you had to and you a ruler, but best would be to measure it with our compass. And so, I can see that it goes through K, and then it goes through K prime. So these are the same lengths. Similarly, I can measure from the line M to L, and then to L prime, and they're about the same lengths, plus or minus my human error. So we have that those two are congruent, and these two are congruent. So we now have shown that the line of reflection is the perpendicular bisector of the pre-image point to image point and pre-image point to image point. And these are the formal definitions that we use for transformations.